Hey everybody, today I will be going through Learning Target 4 from Checkpoint 2, going through some of the solutions and hopefully providing some tips and strategies that might help you for some of the future checkpoints if you didn't get this one on the first try. So the first question is asking us to label graphs with the correct choice given three equations. So the first step for this one will be determining whether they're increasing or decreasing. And we can determine this by plugging or just thinking about plugging in a value for x. So as x increases for this first one, we should expect y to increase as well, since it's like a positive exponent. Similarly, for the second one, as x increases, we should expect y to decrease. This is because we can rewrite the equation as y equals 1 over e to the x. And the way we can think about this as x gets bigger and our denominator gets bigger, the value for y will get smaller. And then finally, for y equals the natural log of x, as x increases, y will also increase. That's just based on the definition of what the natural logarithm is. So knowing that y equals e to the negative x is our only decreasing function here, we can just fill in this answer right away. But now we have to figure out whether y equals e to the x or y equals ln of x, which one will increase quicker. And that one would be y equals e to the x. This is just because it's like a positive exponential. So as x gets bigger at a constant rate, y will grow even quicker. So we can fill this in as y equals e to the x. And this one is y to the natural log of x. Whoops. Okay, on to some of the more computational questions. So we're asked in these three parts to solve for x. So looking at this first one, I see we have exponentials on both sides. So I'm thinking that we'll probably want to get rid of these exponentials in some way. We don't really want an e in the final answer. So the first thing I'm going to do is dealing with this left side. We're going to try to get this in the most simplified form possible. So because we have an exponent raised to an exponent, we can basically distribute this 2 into those terms and rewrite it as e to the 4x plus 6. And for this right side, that's pretty much as simplified as it can be, but what I like to do is maybe rewrite it as e to the negative x. This just lets us have e to the something on both sides. So now we have an exponential equal to an exponential. So the best way to resolve this would be to take the natural log of both sides. I hope my handwriting's somewhat understandable. It's not one of my strong suits. But anyway, here we go. We took the natural log of both sides. And then from here, if we have the natural log of e raised to something, we can basically bring these exponents out in front as coefficients. That's one of the rules we're allowed to do with natural log. So we can write this as 4x plus 6 times ln of e is equal to negative x times the ln of e. And one of the properties of natural log is that the natural log of e is just going to be equal to 1. So that leaves us with 4x plus 6 is equal to negative x. And this is just a little algebra problem here. I'll skip that little step, and we're going to get x is equal to negative 6 over 5. That's our final answer for that part right there. For the second part of this question, we're dealing with a logarithm. So basically, we need to rationalize what this logarithm is actually saying. And what it comes down to is x, or what raised to the negative 4th power is equal to 81. Now, dealing with a negative exponent can be a little hairy sometimes, so I'm going to rewrite this as x to the 4th is equal to 1 over 81. And this is a little easier to manage. So then from here, I'm going to take the fourth root of both sides, which leaves us with x is equal to 1 over oops, sorry, this should be a fourth root as well, fourth root of 81. Now, this might not come to instantly, but we know 9 squared is 81, and 3 squared is 9. So this will just be the same as saying 1 over 3, because 3 to the, or 3 times 3 times 3 times 3, we can rewrite that as 9 times 9, which is 81. So 1/3 is our answer here. You know what, I'm just going to write this, just for clarity's sake, as x equals 1/3, just to remember what we were actually solving for. Cool. Now this next one, this is a trig problem here, or like a unit circle problem to be more specific. So one thing to remember is with these inverse trig equations that we're going to be doing, we need to remember the domain for like cosine and sine. So if I have my unit circle here, hopefully this lets me draw a circle. Okay, perfect. This is our unit circle, and we'll have our axes somewhat like that. When we're dealing with cosine, we're going to be dealing with the first and second quadrants here. Now, what this equation is basically saying is cosine of x is equal to -1/2. We just need to figure out what x is. The cosine of what will give us -1/2. Just looking at a unit circle here, we know cosine deals with with an x value. So I'll go in and draw like a little dot about where that would be. Sorry, more like up here. So that's going to be our -1/2 value. So put something to the -1/2, because that's really all we need to worry about. So based on knowing our unit circle, we can determine that x here would be 2 pi over 3. And based on this, you can always go back and check your equation. What is cosine of 2 pi over 3? Well, that would be -1/2. So perfect. This checks out. Part C is asking us to write this as a single logarithm. And what this is saying is that we want this in the form of ln of something. We don't want multiple ln's, we just want one natural logarithm with every term grouped inside. So I'm looking at this question here, and we have 3 different natural logarithms. And the first step is what I'm going to try to simplify them so that it's just ln of something minus ln of something plus ln of something. And we can do this using the property from right here, where we bring our coefficients out front, or sorry, our exponents out front. And we can do this by writing this as ln of x to the 9th minus ln of y to the 6th plus ln of 7 to the 2nd power. And now we need to apply our logarithm addition subtraction rules. So with addition of logarithms, we basically multiply what's inside. So let's worry about these addition terms first. So that will give us ln of x to the 9th power times 49, because 7 squared is 49. And then we have minus natural logarithm of y to the 6th power. And then from here, using our subtraction rule, which leads to division inside the natural logarithm, we're left with the natural log of x to the 9th times 49 over y to the 6th. That's what it means when we write it as a single logarithm. All right, we're at the last problem now, and this one can be a bit of a pain sometimes to deal with all these exponents and square roots. So the best way to go about it is just be pretty methodical with simplifying everything. So first of all, I'm going to rewrite the numerator as a to the 1/2 times b to the 1/2, and that's all raised to the 3rd power. In the denominator, I'm just going to leave the denominator for now, and we'll worry about the numerator first. So a times the 4th root of b squared. All right. Now, using our exponent ratio and exponent rule that we used earlier, we can rewrite this numerator as a to the 3/2 power times b to the 3/2 power. Now we can worry about the denominator a little bit too. So we have this a out in front. Then inside this parenthesis, we need to remember to square both of those items, the a and the 4th root of b. It's very important to do it to both. So we can have a squared. Now the 4th root of b, which is like, I'll just write this down here in the corner, b to the 1/4, that's the same as the 4th root of b. So if we were to square that 4th root of b, we just end up with b to the 1/2 power, or the square root of b. So now I'm going to simplify that denominator a little more, but let me just rewrite the numerator as well. So we will have a cubed, because there's 3 of those a's, times b to the 1/2. Alrighty, now comes the fun part of simplifying. So when we have an exponent or something to an exponent divided by the same thing to an exponent, we can basically subtract those exponents. So to clarify that, I can rewrite this as a to the 3/2 minus 3 times b to the 3/2 minus 1/2. And this just leaves us with a to the negative 3/2 power times b. And you could also, of course, write this as b over a to the 3/2 power. Those are equivalent, so either of those would be acceptable. All right, so that is learning target 4 for our second checkpoint. All these answers match up with the answer key, but I was hoping to just provide some explanations and strategies that helped me in the class a couple years ago. I hope this all makes sense. If it doesn't, feel free to stop by any of the office hours. We'll be glad to take a look and help you out. But yeah, good luck preparing for the next checkpoint.